Nearly invisible particles of dust rise up even higher into the stratosphere and spread around the world. The dotted green lines show the paths of the radioactive fallout if an all-out nuclear war were to break out in Europe. Nuclear explosions would occur in an instant all over Europe. Dr. Henning Rodhe, Stockholm University, Sweden.
Now, in those areas that are most seriously hit, particularly Europe, North America, and maybe the Japan region, the doses could go well above 100 rad, and that's at least 1,000 times higher doses than the natural levels of radioactivity would produce. Another important fact is that the radioactivity in the fallout will remain for months and years after the war.
The flow of particles would vary considerably according to the weather conditions prevailing at the time, but it would eventually lead toward Eastern Europe and the USSR. If the war also included North America, the fallout would soon blanket the continent and eventually drift towards Europe. Any discussion on the spread of fallout from nuclear warheads must also include the likelihood of attacks on nuclear power stations. Nuclear reactors contain large amounts of long-lived radioactive isotopes like strontium-90 and cesium-137. And if these were released into the atmosphere, it would make huge areas uninhabitable for a very long time. And in war, the main objective is to maximize damage to the enemy. There are over 300 nuclear power plants in operation in the world today. The United States has the largest number, 82. Canada has 13 in operation and 11 under construction, 35 in the Soviet Union and 35 in Britain, 36 in France and 27 in Japan. If the core of a nuclear power plant with its concentrated radioactive fuels is destroyed, the fine particle fallout that results will be extremely deadly for a long time. The following shows the dramatic results when nuclear reactors become targets. First, the fallout pattern 1 week after an accident has leaked 1/3 of the radioactivity from a typical nuclear reactor into the environment. The ellipse indicates the area in which people will receive at least 2 radiation units, or REMs. 2 REMs is more than 20 times the normal background level of radiation. Secondly, this is the pattern 1 week after a 1 megaton nuclear warhead explodes at ground level without striking the reactor. Now the combined effect. 1 week after a nuclear warhead vaporizes the nuclear reactor with the same 2 REM ellipse pattern. In each of these 3 examples, we assume that a light westerly wind is blowing at 24 kilometers per hour. Clearly, the destruction of nuclear power plants in a war would add enormously to the radioactive fallout which would settle across the countryside and affect everything it touches. Not far from New York is the experimental forest area of the Brookhaven National Research Laboratory. Dr. George Woodwell, director of the Marine Biological Laboratory at the Woods Hole Research Facility, carried out an experiment here on the effects of radiation. A quantity of cesium-137 was placed in the center of a stretch of virgin forest and left there for 18 years. During this time, the surrounding vegetation was subjected to continuous, strong radiation. The experiment began the year before the Cuban Missile Crisis and ended in 1979. The objective was to determine the effect that a nuclear war would have on an ecosystem. In the first 6 months, the giant oak and pine trees perished. Next, the shrubs died out, and finally grasses such as sedge disappeared. What had once been thickly covered woodland had now become a desolate patch of sandy ground. Only lichens and mosses survived. In eastern Japan, a similar study is being conducted at the irradiation nursery of the Central Agricultural Experimental Station. The nursery is surrounded by a high embankment, and the way in is guarded by heavy iron doors. A radioactive isotope, cobalt-60, has been placed in an iron tower in the center of the nursery, and plants are cultivated all around it. Those nearest the tower receive the greatest exposure to radiation. This is the section where experiments are being conducted on wheat. Seeds were sown in November 1983. 6 months later, it should have been time to gather in the crop, but the seeds that had been sown nearest to the tower never sprouted. They had all died. Where the daily dosage had been 135 rems, the plants had eventually appeared, but on close inspection looked like this. Many of them showed abnormal development. Leaves were curled, and some heads contained no seeds. This wheat received 55 rems a day, but here again, development was not normal. Leaves were crooked, heads were light. In this section, research is being done on trees. It is some distance from the iron tower. Even plants that receive low doses of radiation over a long period don't escape the effects of their exposure. A plantation of mulberry trees, green and fresh. At first sight, they seem perfectly normal. But when we look closely, we see that the branches are flat, like wooden planks. This clump of Japanese cedars is a good distance from the iron tower, but the trees have been exposed to radiation over a long period of time. They are now slowly dying. The white tips of leaves, looking as if they were made of wax, stand out clearly among the green. With their cells destroyed by gamma radiation, the leaves have lost the ability to produce chlorophyll. The Japanese and Woods Hole experiments clearly demonstrate the fatal effect a nuclear war would have on crops the world over. Studies are also being conducted on the effects of radiation on animal life. These salmon eggs were fertilized, then divided into 5 batches. Each batch was exposed to a different level of radiation, from 10 rems at the minimum level to a maximum of 500 rems. Two months later, the effects of the radiation are very noticeable. Some eggs have failed to hatch. Some young fish, or fry, have died of exhaustion after hatching. Some have survived, but among these, there are many that are abnormal. Fry with crooked backbones. Abnormal fry were conspicuous among those who had been given 50 rems or more. Those who had been given 250 rems or more all died. One of the very obvious characteristics of a very young fish is its large eyes. Here is one born without eyes. The physical damage suffered by this blind fry was the result of exposure to 50 rems. Dr. Richard Turco.
The post-war environment will be an extremely hostile place for man for quite a few reasons. First of all, the direct explosions themselves causing enormous casualties, destroying the infrastructure of our economic, medical, and civil systems. Scientists are extremely concerned at this time, and propelled high into the atmosphere by those explosions in large numbers, will change the climate of the Earth for a period of time extending from months to years perhaps, causing severe after effects that will fundamentally affect the way people could survive in the aftermath of a nuclear war.
In a total nuclear war, the world's oil installations would go up in flames, one after another. Approximately 1 billion tons of oil fuel in the industrialized countries would burn, putting 500 million tons of smoke into the atmosphere. And in the cities, combustible materials such as buildings, asphalt paving, and oil products would burn, releasing 1.5 billion tons of smoke. The forests of the northern hemisphere would contribute a further 300 million tons of smoke. The total amount of smoke from all sources in a nuclear war would be nearly 2.5 billion tons, of which 180 million tons would be pushed even higher into the stratosphere. Once in the stratosphere, smoke particles are held aloft by the upper air currents for a long time and prevent much of the sunlight from reaching the Earth's surface. It would change the climate of the Earth. Dr. Turco.
The amounts of smoke and dust that are presently projected for a war of 10,000 detonations or more are so large and so unprecedented in magnitude that it seems very likely that the climate of the Earth will be affected. This because the sunlight will be attenuated in the atmosphere rather than reaching the surface of the Earth.
I would like to...
In December 1983, a public forum was held in Washington. The subject was the climate after a global nuclear war. Scholars from both the United States and the Soviet Union were invited to attend. Dr. Vladimir Alexandrov, a member of the Soviet Academy of Sciences, presented the results of research done in the USSR.
Minus 20 or something like this. In January, it will be something minus 40, minus 60 Fahrenheit.
The results obtained by the scientists from both countries, working with their different methods, pointed to the same conclusion: the world would freeze after a nuclear war.
Over Saudi Arabia, up to minus 50 degrees centigrade. Over West Siberia, minus 50 degrees centigrade. Over Latin America, minus 22 degrees centigrade, and so on.
Prison all nuclear production.
All the scientists who attended the forum emphasized the need to rid the world of nuclear weapons.
Make it, we expect some freezing of our planet. No choice in this case.
More weapons means less security. Less national security for the United States, less national security for the Soviet Union, less security for the planet Earth.
These images show the movement of clouds from January to July. And they were made by means of the Japanese meteorological satellite, Himawari. The white patterns appearing and disappearing are clouds indicating the movement of the atmosphere. From their movement, you can see that the Earth's atmosphere is clearly divided in two at the equator, north and south. The two systems move independently. This pattern of movement would change rapidly after a nuclear war. If, for example, a total nuclear war should break out on a day in July,